Hello, welcome back to Math with Patrick. Today is July 13th, and we're solving problem number 194 from the Daily Epsilon calendar. And here we have an equation, and we need to figure out what value of x will satisfy this equation. And I'm noticing that this 12 is pretty similar to this 13, right? Like it's only one off. And so I'm going to actually set out to prove this generally. I think that this left-hand side is going to be equal to 1 plus 1 over, and then just 1 less than x, right? Because x is supposed to be 13 today. That's today's date. 12 is 1 less than 13. So I'm going to put x minus 1 right here and hug that in parentheses. And then up top, this is another 12. I'm going to represent that by another x minus 1. And I'm not quite sure that they're equal yet, but I would really like to show that it's true. And if it is, then it just immediately proves this equation. And further, it also proves a whole bunch of other equations. Like maybe if today's date were the 15th instead, all we'd have to do is replace both of these 12s with 14s, and then we'd have this exact same problem on our hands. So I want to do something a bit more broad and prove kind of a family of equations rather than just this one. And I think what I'll do is I'll start manipulating the left side to look like the right side. The first thing I'll do is I'll negate my exponent, and I'll do it kind of like this. Actually, I didn't even negate it. So if I have, say, a difference, say 2 minus 4, that's negative 2. And I'm kind of looking right here as my example. And if I swap the terms, because the x and the 1 hop on both, or they switch sides of that minus sign, but then if I include another negative sign on the outside, I still do get negative 2. So I actually haven't changed the value of the left side just yet. And actually my goal is to not change the value of the left side. So I'll keep the inside part just the same. And I actually want to use this negative exponent in a different way. Rather than using it up here, I want to apply it down here. Essentially, negative exponents flip what's on the inside of like the parentheses here. So like 5 to the power of negative 1 is going to be the same thing as 1/5. And then if I had like 5 to the power of negative 2, I can like use that negative sign to flip the inside, and that 2 is going to stay put. So I'm going to flip the inside by just doing 1 over all of this stuff. Oops, that's supposed to be a minus sign. And then I will keep the exponent the same, x minus 1. So I'm kind of close, right? I've already matched the x minus 1 to the x minus 1. And now all I have to do is show that this is equal to that. And it's not quite clear just yet, so let's keep going. I don't like having fractions within fractions, so I'm going to multiply by x over x here. That's going to just make the numerator x. And then in the denominator, it's going to distribute to both of these terms. So I get x minus x over x. And as long as x isn't 0, I can call x over x 1. So I guess that's a little catch here where I'm like proving all different cases. If x is 0, maybe some weird stuff is going to happen. But as long as x isn't 0, we're okay. So this is still all to the power of x minus 1. Just double checking. It still doesn't quite look like what we have over here on the right side of the equation. So I'm going to do a little strategy where I'm going to split this fraction. It's a little silly, but I want to do minus 1 plus 1 on the top. Hopefully you and I agree that's not going to change its value. And another rule I'm going to apply here is that I can kind of distribute a denominator. So like 3 plus 4 over 5, this is just 7/5. But I could also do 3/5 plus 4/5 like that. And this is kind of me distributing that 5 to both the 3 and the 4. So I'm going to choose to distribute the denominator here to the x minus 1. I'll keep that sign the same, this plus sign right here. And then I want to distribute that x minus 1 denominator to the plus 1 over here on the right side. And I'm still going to keep all of this in parentheses to the power of x minus 1. And here, as long as x isn't equal to 1, I can call this the number 1. Right? Because if x were 1, I'd have 0 over 0. That would be this weird indeterminate form because I'm dividing by 0. But if x is any other number that isn't 1, it's totally fine. And I can call it 1 plus 1 over x minus 1, and then to the power of x minus 1. And this is precisely what we have here on the right side of the equation. So as long as x is not equal to 0 and not equal to 1, then this equality holds true. And that kind of makes sense from the very, very beginning, because we can kind of see here how we would be dividing by 0 on this side if x were 0, and we would be dividing by 0 on the other side if x were 1. But as long as those two conditions are true, which they are because x is 13 for today, then this equation always holds true no matter what. So there is my solution. If you're curious what this number is, do it yourself. I don't know. It's going to be some weird long decimal. I think this is actually a form that approximates the number e. So I'm guessing it's going to be near like 2.6 or 2.7. But that's just a hunch, and you can try it out for yourself to see what the number actually is. But I'm all done. That's my solution, and I'll see you tomorrow. Bye. Just kidding. If you've stuck around for this long, you deserve a treat. So here he is. Look at the guy. It's Quill again. Oh my goodness. So here's the boy. His name is Quill. He's 3 turning 4 in a month, and he is such a chiller. So he says thanks for watching too, and we will both see you in the next video. All right, bye for realsies.